Welcome back to this final section on sanitation systems. The next few templates that we'll discuss are all based on transporting black water offsite, so away from the point where it's generated, to a more centralized point where it can be treated along with the black water generated by other households. This system of black water treatment with effluent transport is a little more complicated than a traditional sewer-based system that would exist in a large European city, because only the effluent from the storage technology is transported. Each toilet, or group of toilets, is connected to some type of collection and storage technology. This produces sludge, which must be periodically removed and treated as in the previous systems, but now the solids-free effluent can be transported easily through small diameter sewers without the risk of clogging. The effluent can then be treated in a centralized treatment technology like a constructed wetland. The previous systems that we looked at that relied on infiltration were not appropriate for dense areas because of the holding capacity of the soil. That is not the problem for this system because the effluent is transported in impermeable pipes away from the community. Here you can see the construction of a community-scale ABR and the solids-free sewer that connects the houses to it. This system would be suitable for a very dense urban context, irrespective of the groundwater or soil conditions. The solids-free sewers are being laid underneath these paving stones. This system, black water transport to semi-centralized treatment, is the typical system for most European and North American cities. A flush toilet generates black water, which is transported through a sewer to some sort of treatment. Notice here also that the black water will require some sort of pre-treatment to prevent the solids from clogging some of the more treatment systems. Even robust systems like those based on activated sludge should still include some sort of pretreatment just to ensure that no rubbish enters the treatment technology. Effluent that is destined for discharge into the environment could require some sort of post-treatment. This would ensure that the levels of pathogens, nutrients, or other constituents do not exceed environmental limits for the discharge. The final slide is basically the water-based version of the urine diversion system that we saw in the beginning. Certainly, it's not a very common or popular system yet, but it's becoming more commonplace, and it is the system that operates in the EAVOG building in Zurich. Here you can see what the urine storage tanks in our buildings look like. But before we can harvest the urine, we need to start at the beginning, at the user interface. The system requires a urine diverting flush toilet. This allows for the separation of urine and brown water, which you'll remember is the combination of feces and flush water. The brown water is then transported through an existing sewer network to a centralized treatment facility. Urine does not provide a lot of volume to the overall wastewater mix, but without it, the nutrient quality in the brown water is much lower and may require less treatment to meet discharge standards. The sludge must be treated as in the previous systems, but because there is less liquid, remember that there will also be less flush water if urine is not flushed, the sludge may be thicker and easier to dry. The urine, of course, can be used directly after a sufficient storage period. However, because this system is best suited to dense areas or buildings, the large volume of urine may be difficult to use locally or alternatively transport it to where it's needed. We covered a lot of material in this module on sanitation systems, but the key points are simple. We can use system templates to help design complete logical systems that do not skip any products or processing. A system template is essentially a matrix of products and functional groups with specific technologies at the intersection point. There are 9 different system templates that can be used to generate hundreds of possible systems, and realistically, there could be other system templates, but these are the ones that we work with at Sondeck. Although the system templates can help in the initial phases, they must be used in conjunction with good engineering and local understanding. In Module 4, you will see and examine some different case studies in which sanitation systems either worked out fairly well or sometimes not so well. Looking forward to seeing you then.